Hello everyone, I am Soumya, pursuing B.E.CSE in SETHU Institute of Technology. In this video, we are going to see about Hadoop architecture. Introduction. Here, big data, what is Hadoop, components of Hadoop, MapReduce. These are the important topics for anyone who works on big data. They need to learn these topics must. Hdfs, Hadoop Distributed File System, Hdfs architecture, yarn, yet another resource navigator, and Hadoop common or common utilities. These are the topics we are going to see in this session. Let's move on to the topic. Big data. Big data is a collection of large data sets that cannot be processed using traditional computing techniques. In simple words, big data is nothing but a collection of large amount of data. For example, the volume of data Facebook or YouTube require it to collect and manage on daily basis. They need to daily collect and manage these volumes can fall under the category of big data. Big data contains a large amount of data that is not being processed by traditional data storage. It is used by many multinational companies to process the data and business of many organizations. There are 5 views of big data that explains the characteristics. The 5 V's are volume, veracity, variety, value, and velocity. These are the 5 V's of big data. Volume is known as a huge amount of data. Volume means a huge amount of data. Veracity. Veracity is an inconsistency and uncertainty in data. Inconsistencies and uncertainty in data. Variety. Variety means different formats of data from various sources. Value. Value extract a useful data. Value means a valuable. Extract a useful data. Velocity. Velocity, we all know that it's a high speed. Velocity means speed. High speed of accommodation of data. Volumes. The name big data itself is related to an enormous size. Big data is vast volumes of data generated from many sources. Variety. Big data can be structured, unstructured, and semi-structured that are being collected from different sources. These are known as velocity. Veracity. Veracity means how much the data is reliable. Value is essential characteristics of big data. Last, velocity. Velocity plays an important role compared to others. Velocity creates the speed by which the data is created in real time. Next, what is Hadoop? As we all know, Hadoop is a framework written in Java that utilizes a large cluster of commodity hardware to maintain big size of data. Hadoop works on MapReduce programming algorithm that was introduced by Google. It helps in processing the data in parallel manner. Hadoop stores large volume of data on several node machines. Today, lots of big brands are using Hadoop in their organization to deal with big data. Hadoop works on MapReduce algorithm that was introduced by Google. Today, lots of big brand companies are using Hadoop. For example, the companies like Facebook, Yahoo, Netflix, eBay, they are using this big data. Hadoop. Components of there are 4 components in this Hadoop. The Hadoop architecture mainly consists of 4 components. They are MapReduce, Hdfs, which is Hadoop Distributed File System, yarn, which is yet another resource negotiator, and finally common utilities. Common utilities is also known as Hadoop common. Architecture diagram. HDFS is the storage unit, MapReduce is the processing unit, and YARN is the resource management unit. MapReduce is also known as distributed processing, and MapReduce is also known as distributed processing. HDFS is also known as distributed storage. YARN is also known as job scheduling and resource manager. Hadoop Common is a Java library and utilities. It is all Java library and utilities or JavaScript. Let's move on to next topic. MapReduce. MapReduce is nothing but just like an algorithm or a data structure that is based on the YARN framework. The major features of MapReduce is to perform the distributed processing in parallel in a Hadoop cluster, which makes Hadoop working so fast. When you are dealing with big data, serial process is no more of any use. Hadoop working so fast. When you are dealing with big data, serial processing is no more. The major features of MapReduce is to perform with distributed parallel in a Hadoop cluster. MapReduce has mainly of two tasks. They are map tasks and reduce task. In first phase, map is utilized, and in next phase, reduce is utilized. Let's understand the map task. Map task is a record reader, map, combiner, and partitioner. Record reader. The purpose of record reader is to break the records. It is responsible for providing key values pairs in a map function. The key is its locational information, and the value is data associated with it. The purpose of record reader is to break the records. It's a main point, that is it is used to break the records. Map. A map is nothing but a user defined function whose work is to process the tuples obtained from record reader. The map function either does not generate any key value pair or generate multiple pairs of these tuples. Next, combiner. Combiner is used for grouping the data in map workflow. It is similar to local reducer. The intermediate key values that are generated in the map is combined with the help of this combiner. Using a combiner is not necessary as it is optional. Combiner can be used or it is not must as those three: partitioner, record reader, and map. Combiner is just optional. Partitioner is responsible for fetching key values pairs generated in the mapper phase. The partitioner generates the shards corresponding to each reducer. Then partitioner performs its modules with the number of reducers. Hash codes of each key is also fetched by the partitioners. These are the four things that is involved in map task. Reducer task. Reducer task has three things: shuffle and sort, reduce, and finally output format. Shuffle and sort. The task of reducer starts with this step. Reducer task's first step is shuffling and sorting. The process in which the mapper generates the intermediate key value and transfers them to reducer task is known as shuffling. Once some of the mapping tasks are done, shuffling begins. That is why it is a faster process and does not wait for the completion of the task performed by the mapper. It will not wait for the completion of the task performed by the mapper. The mapper performance it will not be waited. Next, reduce. The main function or task of the reduce is to gather the tuple generated from map and perform some sorting and aggregation sort of process on those key value depending on its key element. In reduce task, the key value is depending on its key element. Finally, output format. Once all the operations are performed, the key value pairs are written into the file with the help of record writer. First task is record reader, and the final task is final output format. We are writing that key value pairs in file with the help of record writer. Each record in a new line and the key and values in a space separated manner. Second feature component is HDFS. HDFS is a Hadoop distributed file system. Is utilized for storage permissions. It is mainly working on commodity hardware devices, working on distributed file system design. HDFS is designed in such a way that it believes more in storing the data in a large chunk of blocks rather than storing small data blocks. Data storage nodes in HDFS. There are two data storage nodes. They are name node and data node. Name node is said to be an master node, and data node is said to be an slave nodes. Or in name node, all blocks are handled by name node. Monitor and control all data node. Name node will monitor and control all data node. One name node but different data node. It take a photo to recover the data, and it edit log manually required by data node. Data nodes are completely independent. Data nodes are completely independent. A name node is an image file and edit log files. Edit log file is nothing but that tracks the modifications. Edit log files tracks the modifications. Name node works as a master in Hadoop cluster, and data node works as a slave in Hadoop cluster. Name node is mainly used for storing the metadata. Metadata is nothing but the data about the data. Metadata can be the transaction logs that keep track of the user's activity in a Hadoop cluster. Data node versus a slave. Data nodes are mainly utilized for storing the data in Hadoop cluster. Name node is used for storing metadata. Data node is used for storing the data in a Hadoop cluster. High level architecture of Hadoop. In this high level architecture, here master is name node which is in the resource management, and slaves contains data node, node manager, map and reduce. These are contains in this slave. Master is a name node which is in the resource manager. HDFS architecture. File blocks in HDFS. Let's understand this concept of breaking down of file in a block with an example. Let's see an example. Suppose you have uploaded a file of 400 MB to your Hadoop distributed file system. Then what happens is this file got divided into blocks of 128 MB, 128 MB and 16 MB. Means 4 blocks are created, each of 128 MB except the last one. Hadoop does not know or it doesn't care about what data is stored in these blocks. In the Linux file system, the size of a file is about 4 KB, which is very much less than the default size of file blocks in the Hadoop file system. As we all know, Hadoop is mainly configured sorting the large size data, which is petabyte. Nowadays, file blocks of 128 MB to 256 MB are considered in Hadoop. Replication in HDFS. Replication ensures the availability of the data. Replication is making a copy of something, and the number of times you make a copy of the particular things can be expressed. HDFS architecture. HDFS architecture. In HDFS architecture, it takes rack awareness. The rack is nothing but just the physical collection of nodes in our Hadoop cluster. A large Hadoop cluster is consists of so many racks. With the help of these racks informations, name node chooses the closest data node to achieve the maximum performance. Next, Hadoop Yarn. Hadoop Yarn. Yarn is a framework. Yarn is a framework on which MapReduce works. Yarn performs two operations, that are job scheduling and resource management. Job scheduling. The process of job scheduler is to divide a big task into small jobs, so that each job can be assigned to various slaves in Hadoop clusters and processing can be maximized. Job scheduler divides the big tasks into small jobs and assign to various slaves in a Hadoop cluster. Job scheduler also keep track of each job is important. Which job has more priority, dependencies between the jobs and all the other informations like job timing, etc. And the use of resources manager is to manage all the resources that are made available for running a Hadoop cluster. Resource manager is to manage all the purpose that are made available for running a Hadoop clusters. Let's move on to see the features of Yarn. Features of Yarn are multi-tenancy, scalability, cluster utilizations, and compatibility. Multi-tenancy. Multi-tenancy is achieved in the clusters by differentiating applications into multiple business units. Multi-tenancy is achieved in a clusters by differentiating application into multiple business units. For example, different queues and users for different types of application. Different queues, different users for different types of application. Security and privacy can be achieved by configuring Linux and Hdfs permissions to separate files and directories to create tenant boundaries. Multi-tenancy is to create tenant boundaries. Scalability. Yarn is designed to be highly scalable and can handle thousands of nodes in a cluster. It can scale up or scale down based on the requirements of the application running on the clusters. It is known as scalability. Cluster utilization. In this cluster manager works as a distributed computing framework. It also maintains job scheduling as well as resource management. It combines a central resources manager with container application coordinator and node level agents. It combines a central resource manager with containers, application coordinators, and node level agents. Compatibility. Yarn PNP was designed to use the exact same public interfaces as other package managers, with different being kept to what already were implementation details. It is known as compatibility. Yarn features are multi-tenancy, scalability, cluster utilization, and compatibility. Yarn performs two operations: resource management and job scheduling. These are the two operations. Job scheduling is dividing big jobs into small jobs and assigned to various slaves. A resource manager is to manage all the resources that are made available for running a Hadoop. Finally, Hadoop Common or Hadoop Utility. Hadoop Common or Hadoop Utility. Hadoop Common or Hadoop Utilities are nothing but our Java library and Java files, or we can say the JavaScripts. Hadoop Common Utilities are Java library, Java files, or we can say the JavaScripts that we need for all other components present in a Hadoop cluster. These utilities are used by Hdfs, that is Hadoop Distributed File System, YARN, that is yet another resource negotiator, and MapReduce for running the clusters. These are the utilities used by Hadoop. Hadoop common verify that hardware failure in a Hadoop cluster is common, so it needs to be solved automatically in software by Hadoop framework. That's all about these Hadoop architecture. Let's see the overviews of these topics. Big data. Big data is a collection of large data sets. Big data contains a large amount of data that is not being processed by traditional data storage. We have seen 5 V's in this big data. Those 5 V's are volume, veracity, variety, value, and velocity. Volume means a huge. In this volume means a huge amount of data. Veracity is inconsistencies and uncertainty in data. Then variety means we know that variety is a different, so here variety is a different formats of data from various sources. Value, extract useful data. Then the last fifth V is velocity means we all know that a high speed of accommodation of data. This is an overview of big data. Let's move on to Hadoop. Hadoop is a framework that allows you to store a large volume of data on several node machines. Hadoop is framework written in Java. Hadoop works on MapReduce programming algorithm that was introduced by Google. Today, lots of big brand companies using Hadoop. A Hadoop architecture consists of 4 components. The components are MapReduce. We have seen these 4 components: MapReduce, Hdfs, YARN, common utilities, or Hadoop common. First, let's see about see an overview about MapReduce. MapReduce is nothing but just like an algorithm. The major features of MapReduce is to perform the distributed processing in parallel in a Hadoop cluster, which makes Hadoop working so fast. When you are dealing with big data, serial processing is no more of any use. In MapReduce, we have seen about 2 tasks. They are a map task and reduce task. It divided phase wise. In first phase, map is utilized, and in second phase, reduce is utilized. Big data gives an input to map, and it reduces the tasks and gives us an output. Here we can see that input is here we can tell that input is provided to map function, then its output is used as an input to the reduce function, and then that we receive our final output. The map task contains 4 things: record reader, map, combiner, and partitioner. Record reader is the purpose of record reader is to break the records. A map is nothing but a user defined function whose work is to process the tuples obtained from record reader. Third type is combiner. Combiner is used for grouping the data in the map workflow. The final one is partitioner. Partitioner is responsible for fetching key value pairs generated in the mapper phase. Then reduce task. Reduce task has 3 things: shuffle and sort, reduce, and output format. Shuffle and sort. The task of a reducer starts with these steps. The first task is shuffle and sort, the process in which the mapper generates the intermediate key value and transfer them to the reducer. Task is known as shuffling. Reduce. Second thing is reduce. The main function or task of the reduce is to gather the tuple generated from map and then perform some sorting and aggregation thought of process on these key value depend on its key element. Finally, output format. Once all the operations are performed, the key value pairs are written into the file with the help of record writer. Now let's see the overview of HDFS. We already seen that HDFS is an Hadoop distributed file system, is utilized for storage permission. It is mainly designed for working on commodity hardware devices working on distributed file system design. HDFS consists of two data storage nodes, name node and data node. Name node is act as a master node and data node act as a slave node. Name node works as a master in a Hadoop cluster that guides the data node. Name node is mainly used for storing the metadata. Data node works as a slave. Data nodes are mainly utilized for storing the data in Hadoop cluster. Data nodes store the data in Hadoop cluster. Name node stores the metadata. And then we see an high level architecture. Let's see that high level architecture. In high level architecture, master name node is a master. Resource manager, which is in resource manager, and three slaves contains data node manager, and map reduce. HDFS architecture, data in HDFS is always stored in terms of blocks which are divided into small blocks. HDFS architecture, rack awareness. The rack is nothing but just the physical collection of nodes in our Hadoop clusters. The fourth component is a Hadoop yarn. Yarn is a framework on which MapReduce works. Two operations: job scheduling, resource management. Job scheduling is divide big tasks into small jobs, so that each job can be assigned to various slaves in a Hadoop clusters and processing can be maximized. The second operation is resource management. The use of resource manager is to manage all the resources that are made available for running a Hadoop cluster. We also see the features of yarn, that is multi-tenancy, scalability, cluster relation, compatibility. Multi-tenancy, it can scale up or scale down based on the requirement of the application running on the cluster. Second thing, scalability, it can scale up. Multi-tenancy is achieved in the cluster by differentiating application to multiple business, and scalability is scale up or scale down based on the requirements of the applications. Cluster utilization, it combines a central resource manager with container application coordinator and node level agents. Compatibility is with different being kept to what already were implementation details. Finally, Hadoop Common. Let's see the overview of Hadoop Common. Hadoop Common or Hadoop utilities are nothing but Java library and Java files, or we can say the JavaScript. Java library, Java files, or JavaScripts that we need for all other components present in Hadoop clusters. The utilities are used by HDFS, yarn, and MapReduce for running the clusters. Hadoop cluster is common, so it need to be solved automatically in software by Hadoop framework. The fourth last component is Hadoop Common or Hadoop utilities. The utilities are used for Hadoop distributed file system, yet another resource negotiator, and MapReduce, which contains map task and reduce task for running the cluster. That's all about this Hadoop architecture. Thank you.